Describe how to sketch the fifth figure in the pattern. Then sketch the fifth figure. To describe how to sketch the fifth figure in the pattern, first notice that figure 1 has a length and width of one box. Figure 2 has a length and width of two boxes. Figure 3 has a length and width of three boxes. And figure 4 has a length and width of four boxes. Therefore, each figure has a length and width of as many squares as the figure number. Following this pattern, the fifth figure will have a length and width of 5 boxes. So, you can sketch the fifth figure in this pattern by adding a fifth square to each end of the squares as shown. This gives you a sketch of the fifth figure in this pattern. Make and test a conjecture about the product of a negative integer and a positive integer. To make and test a conjecture about the product of a negative integer and a positive integer, the first step is to find a pattern using a few groups of small numbers. For example, the product of 1 and negative 2 is negative 2. The product of negative 3 and 7 is negative 21. The product of negative 4 and 5 is negative 20. And the product of 8 and negative 9 is negative 72. Notice that each of these products is negative. So this seems to be the pattern. Now that you've tested a few groups of small numbers, the second step is to make a conjecture. In step 1, you noticed that each of the products were negative. So your conjecture could be the product of a negative integer and a positive integer is negative. Now that you've made a conjecture, the third step is to test your conjecture using other numbers. For example, the product of 6 and negative 7 is negative 42. Because this product is negative, this test supports your conjecture. In addition, the product of negative 8 and 3 is negative 24. Because this product is negative, this test also supports your conjecture. Finally, you could test negative 14 times 13. This gives you negative 182. Because this product is negative, this test supports your conjecture as well. A student makes a conjecture about absolute values. Find a counterexample to disprove the student's conjecture. The absolute value of the sum of two numbers is equal to the sum of the two numbers. A counterexample is a specific case for which the conjecture is false. So, to find a counterexample for this conjecture, you need to find two numbers whose sum is not equal to the absolute value of that sum. For instance, you can choose 3 and -5. The sum of these two numbers is 3 plus -5, which is equal to -2. The absolute value of the sum of these two numbers is equal to the absolute value of 3 plus -5. When you simplify, 3 plus -5 gives you -2, and the absolute value of -2 is 2. -2 does not equal 2. So, in this case, the sum of two numbers is not equal to the absolute value of that sum. Therefore, this is a counterexample to this conjecture, and because a counterexample exists, this conjecture is false. If a figure is a square, then it is a rectangle. You know that quadrilateral ABCD is a square. Using the law of detachment, what statement can you make? The law of detachment states that if the hypothesis of a true conditional statement is true, then the conclusion is also true. In this problem, you are given the conditional statement, if a figure is a square, then it is a rectangle. The hypothesis of this conditional statement is the figure is a square, and the conclusion is it is a rectangle. Now, you are also told that quadrilateral ABCD is a square. So, the hypothesis of the conditional statement is true. Because the hypothesis is true, the conclusion is also true by the law of detachment. Therefore, using the law of detachment, you can state that quadrilateral ABCD is a rectangle. If possible, use the law of syllogism to write a new conditional statement that follows from the pair of true statements. A. If soccer practice is canceled, then you can go to the mall after school. If it is raining today, then soccer practice is canceled. And B, if a figure is a rectangle, then all interior angles are right angles. If a figure is a square, then all interior angles are right angles. The law of syllogism states that if the conclusion of one statement is the hypothesis of another statement, and if both of these statements are true, then you can write a new conditional statement with hypothesis P and conclusion R that is also true. In the pair of statements in Part A, notice that the conclusion of the second statement is the hypothesis of the first statement, and you are told in this problem that both of these statements are true. The order in which the statements are given does not affect whether you can use the law of syllogism. So, you can use the law of syllogism to write a new conditional statement that follows from this pair of statements. Let hypothesis P be, it is raining today, and let conclusion R be, you can go to the mall after school. So, by the law of syllogism, the new conditional statement that follows from this pair of statements is, if it is raining today, then you can go to the mall after school. In Part B, the hypothesis of the first statement is, a figure is a rectangle, and the conclusion of the first statement is, all interior angles are right angles. The hypothesis of the second statement is, a figure is a square, and the conclusion of the second statement is, all interior angles are right angles. As you can see, neither statement's conclusion is the same as the other statement's hypothesis. Therefore, it is not possible to use the law of syllogism to write a new conditional statement that follows from this pair of statements. The table shows the sum of the measures of the interior angles in various polygons. What conclusion can you make about the sum of the interior angles in an n-sided polygon? To make a conclusion about the sum of the interior angles in an n-sided polygon, first notice that the sums of the interior angles in the various polygons are all multiples of 180 degrees. 180 degrees is equal to 1 times 180 degrees. 360 degrees is equal to 2 times 180 degrees. 540 degrees is equal to 3 times 180 degrees, and 720 degrees is equal to 4 times 180 degrees. Furthermore, notice that the number that 180 degrees is multiplied by in each case is 2 less than the number of sides of the polygon. The sum of interior angles of a triangle can be written as the quantity 3 minus 2 times 180 degrees. The sum of the interior angles of a quadrilateral can be written as the quantity 4 minus 2 times 180 degrees. The sum of interior angles of a pentagon can be written as the quantity 5 minus 2 times 180 degrees, and the sum of the interior angles of a hexagon can be written as the quantity 6 minus 2 times 180 degrees. So, the sum of the interior angles of a polygon is equal to the number of sides minus 2 times 180 degrees. If you let n equal the number of sides, you get the quantity n minus 2 times 180 degrees. Therefore, you can conclude that the sum of the interior angles in an n-sided polygon is the quantity n minus 2 times 180 degrees. Decide whether inductive reasoning or deductive reasoning is used to reach the conclusion. Explain your reasoning. A. If the sum of the digits of a number is divisible by 3, then the number is divisible by 3. The sum of the digits of the number 147 is 12. So, the number 147 is divisible by 3. And B. Each time you forget to do your math homework, your parents take away your phone privileges for a day. So, the next time you forget to do your math homework, you will lose your phone privileges. Inductive reasoning uses specific examples and patterns to reach a conclusion, while deductive reasoning uses facts, definitions, accepted properties, and the laws of logic to reach a conclusion. In Part A, first notice that the given set of statements uses divisibility rules and facts about the number 147 to reach the conclusion. In addition, notice that the first statement is a conditional statement in which the hypothesis is the sum of the digits of a number is divisible by 3, and the conclusion is the number is divisible by 3. The second statement, the sum of the digits of the number 147 is 12, makes the hypothesis true because 12 is divisible by 3. Because the hypothesis is true, the third statement goes on to say that the conclusion is true as well, or in this case, that the number 147 is divisible by 3. So, overall, this reasoning reflects the use of the law of detachment. Therefore, deductive reasoning is used because facts and the law of detachment are used to reach the conclusion. In Part B, notice that the first statement describes a pattern. Each time you forget to do your math homework, your parents take away your phone privileges for a day. Following this pattern, the next statement goes on to conclude that the next time you forget to do your math homework, you will lose your phone privileges. Therefore, inductive reasoning is used because a pattern is used to reach the conclusion.